Hey, everybody, and welcome to Metric Conversions, dimensional analysis to metric conversions. Okay. Again, guys and gals, if you weren't in class, that's okay. We're going to quickly go through this. First of all, everybody sees this word conversions and loses their mind. Conversions, just a fancy word for change. Okay. That's all we're doing is we're making some change. Okay. We're moving something from the others. In middle school, you may have heard the term King Henry died by drinking chocolate milk. Okay. I don't know if you've ever heard that before, but a lot of people tend to have heard it. So I use that a little bit. All right. If we look at this, if we look down here at length, mass, and volume, okay, these are three different types of measurements. If you look at these three boxes, box 1, 2, and 3, you can make some observations here. If you notice within the boxes, each box, you'll see there's numbers. Well, these numbers are the same in each of the boxes, just the numbers, just talking about the numbers themselves. Now, not every number is the same, but each number is the same throughout that actual box. Like if you look at box 1, box 2, box 3, those numbers are the same pattern, each one. Some of you might be saying, Mr. Timo, wait a minute. Each one of these little words in length, meter, is the same in each one of these, and you'd be 100% right. In mass, each one is a gram. Okay, and each one in volume says liter, not liter, but liter. Okay, and last but not least, some of you are going, wait a minute, Mr. Tima, the fronts of these words, kilo, hecto, deca, deci, centi, milli, those are the same within each box and across the boxes. That is not a coincidence. That's actually a thing. So if you notice, the red are the same in every box and the purple are the same in every box. Okay, it's when we get to the blue that things may change a little bit. And we'll talk about that as we get going. Okay, now if you have your notes in front of you, this is the unit conversion box. Okay, and this is very important. This is kind of like the little stone tablet that helps you solve all of these. Okay, but we're not even ready for that yet. First off, we need to make sure that we understand this example right here. We need to know some terms. The first term is, first of all, this is a kiloliter. Okay, this K and this L are very important. First of all, this L is not just called an L, it's called the base. Okay, and the base is just a fancy thing for saying what we are measuring. Okay, so the base is what we are going to measure, what we are going to measure. All right, the front part is called the prefix, and that's a fancy little English word, but all prefix really means in science is the prefix is the converter. Okay, it's the converter. Okay, all right, the converter, well, that's where this comes in. That's what this little box is telling us, what the converter is. Now, notice everything in here is based on the base unit. And remember, what is a base unit? A base unit is something that only has one letter. So if I see kiloliter, that's not a base unit. It has two letters. A base unit has one letter and is only made up of the base. Now on here, we have meter, we have gram, and we have liter. There are some other ones we talked about. What about one with time? That's second. What about one with force? Sir Isaac Newton. And then remember we talked about when we were talking about computers, we were talking about a byte, okay, like a megabyte, a kilobyte, stuff like that. All right. Now in class, we talked about how to read these. All right. And it's a little hard to see on here, but if we looked at a regular meter stick and I split that meter stick into 10 equal pieces, each one of those little 10 equal places, I know that's not 10, but each one of those would be called a decimeter because there are 10 decimeters in every one base unit. If I was to split this meter stick into 100 things, then 100 centimeters are in one base unit. A millimeter would be if there were 1,000 lines on that meter stick. If I was able to split that meter stick into 1 million pieces, it would be a micrometer. And then if I split it into a billion pieces, that would be a nanometer. 1 billion nanometers in every 1 meter. Now, on the opposite side, on the top, it's a little harder to see this on the top because the top's a little harder to understand. All right. And on the top, it's a little harder. The top is a little harder to do because you have to think about it this way. If this is my 1 meter stick and I wanted a decameter, okay, a decameter is actually if I had 10 meter sticks together. If I had 10 of these meter sticks together, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I laid those out in one giant line. If this was one giant line, one of these would be 1 meter. Okay? Well, a decameter, the base, 1 meter, is 1/10. That's what that actually means. 0.1 actually means 1/10. So 1 base unit is actually 1/10 of a decameter. Okay? The base unit is actually 1/100th of a hectometer. The base unit is 1,000th of a kilometer. That means if I had to get a kilometer, I'd need 1,000 of these bases. If I needed a mega, I need 1 million bases because this is 1 millionth and 1 billionth would be a giga. So a lot of times we think about these like bytes. When you have a gigabyte, that is 1 billion bytes, or a byte is 1 billionth of a gigabyte. Don't worry, you'll be good on these as we get going. All right. So here is our magical kind of formula. This is hugely important, okay? This formula is hugely important. And there are some terms here that are even more important. First of all, notice this word right here, unit. It does not say number. It says unit. So for example, if I wrote 2 centimeters down, what is 2? Is 2 a unit? No, 2 is literally a number. Okay, I know that seems crazy to some of you. Are going, yeah, that's dumb. Why do you say that? But what is centimeter? Centimeter is a unit, okay? And this is what's really important, okay? The idea of realizing what a number is and what a unit is. So notice this thing that says unit you have, or unit that you want over the unit that you have. All right. So we'll keep flipping back and forth here a little bit, but let's try to work through one of these, okay? So right here, we're starting with 10 meters and we're going to millimeters. Now, the first thing you need to ask yourself is this a base unit? Does it have one letter? The answer is yes. So that is what we call a one step, okay? Don't worry about why it's called a one step. We'll get to that here in a second, okay? But here you go. If we look up here at our formula real quick, it says, what are we doing first? The first thing we're doing is taking our given and putting it over 1. So literally, don't just put a number 1 here. You literally have to write 10 meters over 1 and draw a fraction bar. Now, the unit that you have goes on the bottom. Now, notice it said unit. What is the unit? Is 10 the unit? No, the meter is the unit. So we're going to put the meter at the bottom. The unit that I want goes on top. Well, in this case, I could go anywhere I want, but I want to go to millimeters, okay? That's the hardest part. This is the absolute hardest part right here because now we have to go to our chart, okay? The second part is going to our chart, and we look up here, okay? So real quick, we go back down here. Which one of these is the base unit, meter or millimeter? Well, you should be saying meter because it has 1 letter. Well, if we come up to our chart and we look, what is the base? The base number that we always put in is 1. So we go down here and we literally put in the number 1. And now we go back to our chart and we could look at anything, but we know we're looking for milli. So we come up here. Be careful. There are 2 lowercase m's. There's this m and there's this m. but I'm looking for, this is meter up here. This literally means milli. It even has it written right here. So we look at this number, which is 1,000. And we come down and we put this 1,000 right here. Okay, so again, this step right here came off of the chart. Okay, this came off of the chart, right? This was the given, okay, which is located right up above here. Okay, now we do some simple math. Okay, we do some simple math. Not all fractions sitting by each other mean cross multiply. Okay, we're going to multiply across the top and we're going to multiply across the bottom. Okay, now units that are on top and bottom can cross out. Okay, just like if I had 2x over 2, you would cross out and reduce that. Okay, if I had xy over x, I can cross those out. Well, I have a meter up here and I have a meter down here, so I'm going to do that. Okay, now 10 times 1,000 is 10,000 millimeters over what's 1 times 1 is 1. 10,000 divided by 1 is 10,000 millimeters. So that right there is our answer. All right, let's try another one real quick. Remember, first thing I need to look at is this a base unit? Does it have one letter? No. Is this a base unit? Yes, it has one letter. Again, I want you to write one step. Okay, we'll get to why that is. It's going to be coming up down here at the third example. All right, if you want to take a second, you can pause this video right now and you can try to do this one on your own. Hopefully you paused the video. Maybe you got stuck. That's okay. We're going to work through this. I'm not going to slide up as much, but you're going to need to look at your chart too. But the first step is to take the given, which is the 400 centimeters, and we're going to put it over 1. And we're going to draw our fraction bar. Up there at the top, it literally said the unit that I have goes on the bottom. The unit that I want goes on top. When I look at my chart up here, I always put 1 in for the base unit. So which one's the base, meter or centimeter? Meter. If I go up there and I look for centi is 100. Again, cross out my like units on top and bottom. I multiply across the top. I multiply across the bottom. That's 400 m or 400 meters over 100. Now, you can think of it as 400 divided by 100, or you could just reduce, cross out zeros, whatever you want to do. Either way, my final answer is 4 meters. Hopefully you got that answer. If you did not get that answer, okay, that's a sign that says, hey, I need help. I need to go ask questions. Okay. All right, here we go. We're going down to the final one. All right. So now, is kilometers a base unit? You should be saying no, it has 2 letters. Is millimeters a base unit? You should be saying no, it has 2 letters. So this is what we call a 2-step, okay, which literally means we're going to do this twice. All right. Now, we're going to take kilometers and we need to go to the base unit. And then from the base unit, we're going to go to meters. Well, what is the base unit? Kilometer, millimeter. You should hear the same word twice or think about what would be that single letter. And the answer is meter. All right, here we go. We're going to do one of the steps. We're going to do the first step. This is the first step right here. All right, so I'm going to come down here like normal and I'm going to write 10 kilometers and over 1. And do this. Now remember, we're only going from 10 kilometers to meters here. Okay, so go ahead and pause the video if you want and try to give it a shot. Hopefully you did that and you're not just listening, and hopefully you at least tried to see where you're messing up. But you're going to have to take my word for the numbers. They're up above, but here we go. 10 kilometers, the unit that I have goes on the bottom because I want it to cross out. The unit that I want, in this case is meters, goes on top. The base unit, we always put the number 1 in for, and meters is the base unit. It's 1 letter. I look up at my chart and I get the answer of kilometer, which is 0.001. That is on the chart up above. Cross out my units on top and bottom. That's 10 meters over 0.001. Now you can put this into your calculator right now, but when we divide by a decimal, it gets bigger. It has to do with something called the reciprocal. You don't need to know that for this class, but I'm going to get the answer of 10,000 meters. That is not my final answer. I repeat, that is not my final answer. If we look up here, we're only sitting right here now. Now we need to do part two. So this right here is not my final answer. This is really just my new given. Okay, this is my new given. Sorry, that I didn't show up very well right there. Not given. All right, so all I'm going to do is I'm going to come over here and I'm literally going to start over. I start out with my given, my new given, shall I say, and put it over 1. And I draw my new fraction bar. Now I'm focused only on the second part. So again, it's like this part, the first part, the part in blue doesn't even count. We're only focused on part 2. Here we go. Go ahead and take a second if you want to stop the video and give it a shot. All right. Hopefully you tried that. Here we go. The unit that I have, meters, goes on the bottom. The unit that I want, now we are on part 2. I want to go to millimeters. I want to get this finished up. I look up at my chart. The base unit is meters, so I put 1 in for it. I look at the chart up there, and 1,000 is under milli. Cross out my like units on top and bottom. I multiply across the top. I multiply across the bottom. 10,000 times 1,000 is 10 million millimeters over what's 1 times 1? 1. Again, we could write this out if you want, but my final answer is 10 million because 10 million divided by 1 is 10 million. Nothing happens. Millimeters. And that right there, guys and gals, is my final answer. I'd write that up in here. All right. Dimensional analysis is something you're going to use as you go through science, no matter where you're at. So it's best that we learn the process. Moving the zeros is very easy, but it's not about just moving the zeros. It's about the process. Again, if you need help, make sure you ask questions. Hope you enjoyed the video. Till next time, Team Atron out.